Program Ebelajau Mathematics Form 4 Chapter 6 Linear Inequalities in Two Variables. With you today, I am Cikgu Wan Malina Abdullah from SMK Gajah Berang, Melaka, and today I will teach you Chapter 6 Linear Inequalities in Two Variables. The content standard for today, we will focus on 6.1 linear inequalities in two variables. Okay, and the learning standard, we have two learning standard here. 6.1.1 represent situation in the form of linear inequalities, and 6.1.2 make and verify the conjecture about the points in the region and the solution of certain linear inequalities. Alright. Okay, let's start our lesson. How do you represent a situation in the form of a linear inequality? Okay, inequalities are used to describe the relationship between two quantities that are not equal. Diagram 1 shows a common warning sign on the road or highway. The warning sign is placed at an entrance of a tunnel. What is the maximum height of a vehicle that can pass through the tunnel? Okay, if you can see diagram 1 here, okay, diagram 1 here, there is a limit here, okay, for the tunnel, 4.75 meter. So in this situation, okay, let the overall height of a vehicle represented by a variable h. So we can write that h is less than 4.75 meter. Okay, so in this situation, only one quantity is involved, that is the height in meters. Okay, now before I continue, I hope you can remember the sign here. Okay, the sign for greater than, less than, greater than or equal to, less than or equal to, because we will use this sign for this chapter. Okay. Okay, next example, diagram 2. Okay, diagram 2 shows the maximum mass of 3-ton lorry when it is loaded and not loaded. What is the relationship between the mass of an unloaded lorry, the mass of a loaded lorry, and the mass of the load? Okay, I think all of you have seen this diagram before, right? Okay, BDM. Okay, if you can see here, BDM and BTM. Do you know what is BTM and BTM? Okay, I will explain to you. Okay, the situation in diagram 2 involve the mass in kg but in two different conditions. Okay, let y is equal to gross vehicle weight. Okay, gross vehicle weight is BDM actually. BDM is in bahasa Melayu berat dengan muatan. Okay, that is BDM. Okay, and let x equal to curb weight, where x is equal to BTM. BTM is in bahasa Melayu berat tanpa muatan. Okay, so to find the value of load, BDM minus with BTM. Okay, BDM minus with BTM. Okay, from the diagram, okay, BDM is 7500 kilogram here. Okay, and BTM is 3410 kilogram. Okay, so value of load BDM minus BTM equal to 7500 minus with 3410 kilogram. Then you will get value of load is equal to 4090 kilogram. Thus, the situation in diagram 2 can be stated as y less than or equal to x plus 4090. Okay, we can write like this lah. So we can write one inequality from the diagram, from the situation, where we can write y less than or equal to x plus 4090. Okay, class. I give you one example. Taufik wants to buy some revision books and exercise books at a book exhibition. He finds that the price of a reference book is Rm14 and the price of an exercise book is Rm9. The maximum amount of money that Taufik can spend is Rm100. Represent the above situation in an appropriate form of linear inequality. So we can write one inequality from the situation, because we know that the price of a reference book is Rm14 and the exercise book is Rm9, and Taufik only can spend Rm100 to buy all the books. Okay, from here, okay, we can write 14 before that. Okay, sorry, before that, okay, we can let x equal to reference books, okay, and y is equal to exercise book. Okay, then after that we can write one inequality here, from here, 14x plus with 9y less than or equals to 100. Okay, I am very sorry because I just use the mouse. Okay, I just use the mouse to write the inequality here, not so proper. Okay, okay, you can write the inequality like this, or okay, or you can write like this, or you can write 14x, okay, less than or equals to 100 minus with 9y, also can. Okay, you want to write like this or write like this, okay, both are correct. Okay, next example 2. Wan Hidayah wants to buy mathematics posters to hang in the mathematics room. The cost of a small poster is Rm12.5 and for a large poster is Rm18.5. Represent the purchase of both posters in an appropriate form of linear inequality if the allocation from the school is Rm150. Okay, so let K is equal to small poster and B is equal to large poster. So how to write the inequality for the given information? Okay, so we can write 12.5, okay, K plus with 18.5 B less than or equal to 150. Okay, you must write, normally we write the inequality, we must write in whole number. So 12.5 we can change it to fraction. Okay, we change it to fraction first. We know that 12.5 is 25 over 2. Okay, 25 over 2, okay, plus with 37, change it to fraction over 2, because 37 over 2 is 18.5. Okay, B, okay, 37 over 2B less than or equal to 150. Okay, so by multiply both sides. Okay, if you multiply both sides of the inequality by 2, okay, we multiply by 2, both sides, multiply by 2. Okay, because we want to cancel the fractional denominator here. Okay, we want to cancel it. Okay, so just times 2, then your inequality will become like this. 25k plus with 37b less than or equals to 300. Okay, so that's the answer. Okay, I hope all of you can understand. Okay, next. Now, 6.1.2. How do you verify the conjecture about points in the region that satisfy a linear inequality? I give you two situations here. Diagram 1 and diagram 2. Okay. While you form 1 before, okay, you already learned how to represent an inequality in one variable using a number line. Okay, so this one. Okay, using number line as in diagram 1. Okay, you already learned while you form 1 before. Okay, but do you know that an inequality can also be represented on a Cartesian plane by shading the region here, okay, by shading the region that satisfy the inequality as in diagram 2, in this diagram, this region. So how to write the inequality? Okay, all the coordinates, all the x coordinates in the shaded region satisfy the inequality x greater than or equals to 1. Right? X greater than or equal to 1. 1, 2, 3, and so on. Okay, so we can write the inequality like this also. Okay, for the Cartesian plane given. Okay, next. Okay, based on diagram 3, okay, diagram 3 shows the types of regions generated on a Cartesian plane when a straight line is drawn. Okay, now we have 4 situations here, 4 diagram. Look at the first diagram. Okay, the first diagram. Okay, given that the line is y equal to mx plus c here. Okay, the line is y equal to mx plus c. Okay, the region, the red one here. Okay, this region is above the line, and and this region, okay, the blue one. Okay, the blue one here is the region below the line. Okay, if now look at diagram number 2. Okay, diagram number 2. Okay, the line is here. Okay, y equal to negative mx plus c. Okay, because the gradient is negative, that's why the line is like this. Y equal to negative mx plus c. So for this diagram, okay, same as example 1, same as diagram 1. Okay, the red region here, okay, the red region is the region above the line, and the blue region here, okay, is the region below the line. Okay, next, diagram number 3. Okay, look at diagram number 3. If you have one line here, okay, the line is y equal to h. Okay, this is your line. Okay, y equal to h. Okay, then the red region, okay, is the region above the line, and the blue region is the region below the line. Okay, and then the last diagram. Okay, number 4. Okay, diagram number 4. The region, the line is x equal to k. Okay, this is the line x equal to k. Okay, the line, the region on the left of the line. Okay, the red region is on the left of the line, and the blue region is the region on the right of the line. Okay, now look at example 3. Draw the straight line y equal to negative 2x plus 6 for the given range. Okay, for x is greater than or equal to negative 1 and x is less than or equal to 5. Okay, and then plot the points 1, negative 2, 4, negative 2, 0, 1, 1, 4, 4, 3, and 2, 6. Okay, and then determine whether the points plotted satisfy y equal to negative 2x plus 6 or y is greater than negative 2x plus 6 or y is less than negative 2x plus 6 here. So how do we solve this example? Okay, look at here. First, okay, how to solve this situation? Okay, from the given equation, okay, the given equation y equal to negative 2x plus 6, okay, now we will substitute with the values of x given, with the given range. We take two values here, okay, so you can take any values, okay, but we take the smallest one and the largest one here. Okay, the range given, so we will take negative 1. Now when x equal to negative 1, okay, when you substitute negative 1 into the equation, okay, you must substitute into the equation. Okay, y equal to negative 2 times negative 1. Okay, now when x negative 1, you sub into the equation. Okay, plus 6, then you get y equals to 8. That's why y equal to 8 here. Okay, and then when x equal to 5, okay, when x equal to 5, you substitute into the equation. Okay, substitute with 5. Okay, so negative 2 times 5 plus 6, you will get negative 4. That's why negative 4 here. Okay, then when you have 2 points, you can draw a line. Okay, you can draw the line for the given equation. Okay, you have 2 points now. Okay, now I give you, okay, now the points given, the points that you already find is negative 1, 8. Okay, negative 1, 8 is here. Okay, you plot the point here. Okay, and then when x equal to 5, y is negative 4. Okay, so when x equal to 5, y is negative 4. So this is the point. Okay, you plot these 2 points and you draw the line like this. Okay, you draw the line like this. Okay, now we will determine whether the points given. Okay, 1, negative 2. Okay, 1, negative 2 is here. Okay, this is the point. 1, negative 2 here. Okay, so based on the line, here is the line. Okay, this point, we know that this point is below the line. So we know that y is less than, okay, y is less than negative 2x plus 6 for this point. Satisfy the point is satisfy y less than negative 2x plus 6. Okay, now let's take point number 2. Okay, number 1 done. Okay, number 2, 4, negative 2. Where is the point? Okay, 4, the x coordinate is 4, the y coordinate is negative 2. So this is the point. Okay, now this point is lies on the line y equal to negative 2x plus 6. So, okay, we know that this point, okay, satisfy this equation. Y equal to negative 2x plus 6 because this point lies on the line. Okay. Next, third point 0, 1. Where is the point 0, 1? Here. Okay, 0, 1. Okay, this point. Okay, this point is uh, below the line. Okay, so we know that this point is satisfy this equation. Okay, this equation. Okay, then the fourth point 1, 4, we can check 1, 4 here. Okay, 1, 4 is line on the straight line. Okay, on the straight line y equal to negative 2x plus 6, so we know that 1, 5 satisfy y equal to negative 2x plus 6. Okay, and the fifth point 4, 3, where is the point? Okay, here, this is the point 4, 3. 4, 3. Okay, this point, okay, is above the line. Okay, above the line. Okay, above the line. So we know that this point satisfy this inequality. Y is greater than negative 2x plus 6. Okay, and the last one, 0.26. Okay, 0.26 is here. Okay, and this point also lies above the line. Okay, so this point is satisfied. Y equal to, y is greater than negative 2x plus 6. Okay, so we can write, okay, like this lah. Okay, points 1, 4 and 4, negative 2 satisfy the equation y equal to negative 2x plus 6. Okay, points 2, 6 and 4, 5 satisfy the inequality y is greater than negative 2x plus 6. And then point 0, 1 and 1, negative 2 satisfy the inequality y less than negative 2x plus 6. Okay, I hope you can understand my explanation here. Okay, last example, example 4. Given the linear equation y equal to negative 3x plus 6, without drawing the graph of the straight line, determine whether the given point satisfy y equal to negative 3x plus 6 or y greater than negative 3x plus 6 or y less than negative 3x plus 6. So we have 4 points here. Okay, we try to solve one by one. Okay, we try A first. Okay, look at A here. Given that point given that point 2, 5, okay, we know that the x coordinate is 2 and the y coordinate is 5. Okay, use the coordinates given, substitute into the equation. Okay, just now, if the equation given is y equal to negative 3x plus 6, use this equation. Okay, so we know that y is equal to 5. Okay, sub with 5, and then at this side, okay, negative 3x plus 6. Okay, substitute x with negative 2. Okay, substitute with x equal to 2. Okay, so negative 3 times 2 plus 6. Okay, so we will get 0. Okay, so at this side is 5. Okay, y is 5 and negative 3x plus 6, we will get 0. So we know that 5 is greater than 0. Okay, 5 is greater than 0. Thus, we know that 0.25 satisfies y greater than negative 3x plus 6. Okay, next. Okay, now look at B. Okay, point 1, 2. We do the same thing. We substitute y with 2, okay, and x with 1. Okay. At this side, when you substitute with x equal to 1, negative 3 times 1 plus 6, then you will get 3. And we know that 2 is less than 3. So, we know that point 1, 2 satisfy the inequality y less than negative 3x plus 6. Okay, because of this one lah, less than 2 is less than 3. Okay, next, C. Okay, the point given is negative 1, 9. We do the same thing. Y equal to 9. Okay, the coordinates of y is equal to 9. Okay, and the coordinate of x is equal to negative 1. Substitute here. Okay, x equal to negative 1. Okay, negative 3 times negative 1 plus 6 is equal to 9. So, we know that 9 is equal to 9. Okay, the value of y is 9. And at this side, we get 9. So, 9 is equal to 9. So, we know that this point negative 1, 9, is satisfy y equal to negative 3x plus 6. Okay, last one, D. Okay, point 0, 8. Okay, the y coordinate is 8 and the x coordinate is 0. Okay, so y is 8. Then substitute x with 0. Okay, negative 3 times 0 plus 6, you will get 6. Okay, and we know that 8 is greater than 6. Okay, 8 is greater than 6. Then 0.08 is satisfy y greater than negative 3x plus 6. Okay, that's all for today. Thank you.